It's time to export the knowledge. In this video, we're going to be dividing polynomials by long division. But first, we're going to look at actual long division. And we're going to divide 7 by 5,000. 7 into 5,000. So what this is representing is 5,000 over 7. These two expressions are equivalent. Now, we do it like this, so we can go vertically down the page. The way we start is that we take 7 and we want to find a multiple of 7 that goes into our first number. So our first number is 5. 7 doesn't go into 5, so I'm going to put a 0. And we're going to look at 50 now. So 50, how many times does 7 go into 50? Well, it can go 7 times. 49. So we write that down there, right? And then we subtract the 2. And we get 1. And then I will bring down my next digit, which is 0. How many times does 7 go into 10? It can go in there once. 7. Subtract. We have a 3. Next digit, bring it down. 0. How many times does 7 go into 30? It can go in 4 times. I wrote it up the top. 28. Subtract 2. And now I don't have a number here to actually bring down. I don't have anything, so I stop and I can write remainder 2. Now, what I can do with this remainder is that I can say that this is equal to 714 and 2/7, just like that. And it becomes a proper fraction. That's all this process is doing. Now, there is some terminology here. So this number 7 here, that is the divisor. This here, we've talked about it already, that's the remainder. This number here, 714, that is the quotient. This number here is the dividend. We don't really need to talk about these terminology really, but remainder is used a lot, so remember that one. And you also need to remember divisor and quotient for later on. Won't necessarily be tested on this, but the remainder, as we'll see, is actually a very important concept. This video is about polynomials, so let's actually do a polynomial division. So we'll have x plus 1, and I'll write my long division symbol, and let's divide a cubic. So x to the 3 plus 2x squared plus x, and we'll do minus 1. What am I going to do? Alright, firstly I need to look at the leading terms of the two polynomials. So this linear factor's leading term is x, and the leading term for this polynomial that I'm dividing is x cubed. So what I always want to do is I want to find some number to times x so I can cancel out x cubed. So in this case, it's going to be x squared. So if I put x squared at the top, and then I times by x squared. So I will get x to the 3, but I also have this plus 1 here as well, so I have to times that as well, plus x squared. I'll draw my line. Now you might like to put a subtraction symbol and put brackets just to help you differentiate what's actually being subtracted, or you can just put a minus symbol. It doesn't really matter too much. Now when we subtract, we'll find that these two terms here will cancel, so I won't even bother doing anything for that, and this here will x squared. Now just like before, I will bring the next term down, plus x, and I will repeat the same process. So now I need to times by x, so I add x at the top times by x squared plus x, and they cancel out nicely. So I will write 0 at the end here and bring down term minus 1. Now I have 0x terms. I can times by 0. I have 0 plus 0. Subtract that, and I still get minus 1. Now notice that I didn't need to do that bit. I could have stopped here and say the remainder was minus 1. But following through the process confirms that there is no constant term and the remainder is indeed minus 1. To show what this is as a fraction, and then how we can implement the remainder. So, what I'm saying is x cubed plus 2x squared plus x minus 1 all over x plus 1 equals x squared plus x, and then I have this remainder negative 1, so I'll say minus 1 over x plus 1. I want to move on to a slightly harder example. Let's just start doing this as usual. So what do I need to times by to cancel this first term? I will times by x squared, put it at the top, x cubed plus 2x squared, and we have an issue. I can't subtract these two terms. They are not like terms. So because I can't subtract them, I can't actually do anything here. So I'm stuck with this weird expression, negative 2x squared plus x. Now I could proceed and solve from here, but now when I want to drop down something, I have to do it in this weird diagonal, right? And imagine if we just had x to the power of 3 minus 1. I would be going diagonal all the way out here, somewhere. I don't want to do that. So, make our lives easier, x plus 2, and we had x to the 3, we will add 0 x squared. So I haven't changed anything, but I have something to actually collect like terms with. Plus x and minus 1. Now, when I do x squared at the top here, x cubed and plus 2x squared, I can subtract these two, negative 2x squared plus x, and I don't have this weird diagonal drop. Now I can proceed minus 2x squared, and then I will have a minus 4x, subtract, now a double negative here, so we're going to have 5x minus 1, and we add times by 5x plus 10, subtract minus 11, and that's our remainder. Alright, now I want to now divide this expression here. Now, a couple of things. We need to put our zeros in here. But we also should be putting zeros up here as well. Again, I don't want to be awkwardly shifting it this way, make collect like terms more difficult than it actually needs to be. So, to help with that, I will put a 0x term here, and I will add an x squared here, and I will do the same here. Now, because it's x to the 5 and I have a constant term right over here, I'm going to have to add a 0x to the 4, a 0x to the 3, a 0x squared plus 0x, and I'm going to have to go through this process quite a few times, but I do have a lot more terms, so the process is going to be slightly quicker. So, what am I going to times by? I'm going to times by x to the 3, and we will just follow the same process. We'll cancel the first term. This will become 0x to the 4 and minus x to the 3. Subtract that, we now have 0 x to the 4 still. And here we actually have an x to the 3 term here. But instead of dropping down 2, now I drop down my next term, 0x squared. And I repeat the process. So I'm going to have I want to cancel out the first term here, which is 0x to the 4. So I will times by 0x squared. I will get 0 plus 0. Right? Subtract. I'm still got my x to the 3 here, and I still have 0x squared. Bring down the 0x. And now I can times by x. So I'll add x times it all, x to the 3. I'll have zeros. I'll have 0, and then I'll have minus x. Subtract. I will end up with nothing. Nothing here. Here I will have double negative, so I'm left with positive x, and then I'll have 2 over here, and that's my remainder. There's no constant term. That's 0. I can go on further if I need to, but see that this step here wasn't really needed. I could have jumped from this step all the way down here if I wanted to. Right? I'm going to do that skip now and just say that is my remainder. So my remainder is now x plus 2. I want to do one last example. Going to get some messy fractions with this, because what am I going to times 2x by to get 3x cubed? Well, I'm going to have to times by 3 over 2 and x squared, right? So already you're going to see that this is going to be a very, very strange and awkward division. But it works exactly the same way. So I'm going to be left with 3x cubed plus 3 over 2 x squared. Subtract 3 over 2, that's leaving a half x squared minus x. Now I'm going to have to times by x something. Coefficient for my x term be a quarter. So now that I'm times by a quarter, I will get a half x squared and plus a x. Subtract the 2. Now I'm going to have negative 5x. Bring down the minus 2. Minus 5 over 8. And I will 5 over x minus 5 over 8. Track that. That's going to become positive. It's negative 16. Negative 16, and I'm going to add 5. It's going to make 11 over 8. My remainder is negative 11 over 8. And that's it, we're done. If we wanted to do this on the CAS, we will go to our calculator document, go menu, algebra, and then there's fraction tools at the bottom there, 9, and then proper fraction, and then we will type in our fraction that we actually want to do. So let's do x to the 5 plus 2, and I'll put brackets around so I don't have to use the control divide. X plus 2, and you can see there, just take note that this term here is our remainder, and all of this is our quotient. That's it for this video. If you have any questions, feel free to contact me on social media or leave a comment down below, and I will see you in the next video.